Right. Good morning. Let's get started today. Thanks. Well, thanks for coming. Monday morning at 9 a.m. Always a lot of fun to be in class. For both of us. Okay, so in case you missed the email, homework 2 was sent out and assigned last night. So there's 4 problems. Going over. First question has to deal with how we decide if a grammar is ambiguous or not in 2 different ways. The second problem is about computing first sets, which we're going to go over in depth. We're going to see an example of doing that today, but it's just applying the rules that we actually all derived on Wednesday. Then the third problem is doing first sets and follow sets for a grammar. And we'll start follow today. Hopefully we'll get into it so you'll have an idea, and then we'll go into an in-depth example on probably Monday. And then 4 is more regular expression stuff, because I want you to, regular expressions are a really important part. So you basically have to, it shouldn't be called hex. That's cool. Copy paste error. Yeah, basically you want to create a regular expression that deals with that English string. So you want to translate the English description into a regular expression. That's better. No, that's not better. Is that better? Is that better? The lighting's weird. All right. Any questions? Yeah.
I looked at your website and there was like a text for the homework, but there was no link for it.
Or is it just a link to Blackboard?
Oh, it's
I
on
fixed
Blackboard.
it this morning.
Okay.
Yeah. Those links. I can't link directly into the Blackboard class for some reason. So, yeah, it just links to Blackboard in general.
As long as I can get it somewhere.
Yes, you should be able to. Cool. Any other questions on homework? Class stuff, homework stuff, midterm in a week. So on Wednesday, we'll do a review. So I think probably today or tomorrow, I'll release like a practice midterm. And on Wednesday, that's what we'll be going over. Is we'll be doing the practice midterm, and then you can ask any questions and that kind of stuff. So the best way to prepare for the midterm is to do this homework, right? Do the practice midterm beforehand, before Wednesday, and then come on Wednesday so we can talk about how you thought about things. If you made some mistakes, we can try and correct them before the midterm on Friday. Yeah.
Are we gonna get as far as lexical analysis for the midterm, or are we just going to be covering up to essentially what we're going to be covering up to today?
Lexical analysis?
Yeah.
The stuff we covered 3 weeks ago.
No.
Syntax analysis is what we're doing now. Yeah. So everything up till next Monday will be fair game. Yeah.
Are we gonna get homework 1 back?
Yes, it'll be graded next week. Any other questions? In the back? No? Alright, lots of head scratching. We haven't covered anything. Okay. Today we looked at first sets and we tried to figure out, okay, how to calculate the first sets, right? So we kind of derived from using examples. We took the examples and we derived kind of general rules for how to calculate the first sets. So let's kind of regroup here. So what is the first set or first function? What is this function? What does it take in? And what does it return?
It takes in a string and returns the first character.
Takes in a string and returns the first character. You need to be more specific.
Terminal or
A string of what? A string of characters? A string of
A string of grammar symbols, which can be terminals, non-terminals, or epsilons.
Yeah, so a string of grammar symbols, right? So that's what the epsilon or the alpha here represents, right? So we have terminals, non-terminals, and epsilons, right? So a sequence, so a string is a sequence, so a sequence of any of those. Yeah. So what does it return then? Somebody else?
set possible terminals.
Say it again.
Set of possible terminals or tokens.
Perfect. Yeah, the set of possible terminals that this alpha strings that alpha generates starts with. Exactly. Cool. So the way to think about this, so what we're going to do is we're actually going to try to think about this as an algorithm, right? So we've generated some rules, and now we want to think about how to use these rules to compute, right? And to be able to compute this first set for any grammar that you give us. We can calculate the first sets of any grammar and any symbols, yeah?
Could you repeat the definition of what first returns?
So first returns a set containing tokens or terminals. For this, since we're talking about context-free grammars, we'll just talk about terminals. But the tokens helps us remind us why we're doing this, right? Because they are tokens in parsing. But context-free grammars are general, general concept. So important things. Okay, so I guess we should clarify. Terminals and epsilon, right? So there can be epsilons in first sets, right? But no non-terminals. If you have any non-terminals in your first set, you've done something horribly wrong. Okay, so usually when we talk about first sets, we want to calculate the first set for every non-terminal in our grammar, right? Just like we saw, because that'll help us differentiate between the rules, right? So what we're doing is we're trying to say, hey, if we can calculate this beforehand, then when we write our parser, we know that if I can determine between two rules just based on one character, then I can do a predictive parser that's very efficient and can create these parse trees. So we're going to first start out with, we're going to say the first set of every non-terminal is the empty set. Right? So this is our base case, this is how we start. So we say, so for example, homework's midterms, right? So we say like, okay, calculate the first sets of this grammar. Your first step is, so when we say calculate the first sets, we mean the first sets of all the non-terminals, right? So for every non-terminal in your grammar, you're going to say the first set of that is the empty set. Then you just apply the 5 rules, right, that we derived. You're going to apply these rules over and over until, what we'll see, nothing changes. Where they don't change any of our current definitions of the first sets. So what was the first rule that we derived? Yeah.
The first of X is the set containing X if and only if X is a terminal.
Yeah, right? So we say, hey, the first set of any terminal is the set containing that terminal, right? So then what was the second case? Yeah.
First, the empty set is, the second to the empty, or empty string.
What's the empty string called?
Epsilon.
Epsilon. Yeah, good. Right? So yeah, so the first of epsilon is the set containing epsilon, right? So why do we have these 2 rules? Why aren't they just one?
Because the empty string is, or epsilon is special.
Because epsilon is special. Yeah, because epsilon is not a term. I mean,
Right, it's nothing.
right, it's not necessarily a terminal. Just like I need to get a little copy of myself. What happens when you forget your coffee mug? I think I forgot it in my other class or something. I don't know where it is. This is not it though. And I had to leave early to make sure I got coffee, otherwise we would have a terrible class today. Alright. And if we have a terrible class anyways, I'm sorry. Okay, so what was our next rule? What did our next rule have to deal with? What was the intuition behind the next rule? Right? These are kind of, so if you think about this as a recursive definition, right? These are the base cases. So when you break everything down, you're going to get to a terminal or an epsilon. Right? So what did the next rule deal with? Yeah.
Our next rule dealt with removing epsilon from something that epsilon could not be the first of.
Correct. But what did it apply to? So what were we looking at? So for terminals, so we did terminals, we did epsilons, right? So what's kind of left?
Non-tokens.
Non-terminals. Yeah, right? That's the third of the grammar symbols, right? So we've taken care of this case, the 2 cases. Now we take care of the third case. So we basically derived the rule and we showed ourselves that, hey, if we have a rule in the form of A produces B alpha, right? So here, so what type of grammar symbol is capital A here? Non-terminal, right? And so how do you know that? It's capitalized, yes, but
Or it's
also
left-hand side?
It has a rule.
yeah, it's on the left-hand side of the grammar production rule, right? So only non-terminals on the left-hand side. That's how you know that. Okay, great. What's alpha represent?
Everything after B.
Everything, all symbols. Terminals, non-terminals, epsilon, a sequence of symbols. What's B?
Another
it doesn't have to be a non-terminal, so I made changes to beta. I think I changed it back because it was annoying using all the Greek characters, but now that I kind of look at it now, I can see that it's a little confusing. But that B just means whatever symbol is there. Terminal, non-terminal, epsilon, whatever.
Wouldn't it, because it's because we were going to say the first of B minus the second containing epsilon, wouldn't it have to be some kind of non-terminal? Because it has to contain more than one character.
Not necessarily, actually. We can look at that in a bit.
Oh, because it could just be.
It could be epsilon, it could be just
epsilon.
A, it could
And
be
then-
just the terminal
And then
A.
you go to rule 2 and
Little
then
a.
it subtracts itself.
Exactly, yes. And then the fifth rule applies, and then you add it back. Cool. Right, so all this rule says, so this is complicated, but it says for every production rule, right? I can calculate the first set of the left-hand side, right? By adding the first symbol on the right-hand side, right, in this case B, taking that, calculating its first set, subtracting epsilon, and adding that to the first of A. So before we had equals here, right, we'd say, well, the first of A is equal to this. Why do we have add? What does add mean with sets? It's kind of,
Union.
yeah, right? So we're saying union that into it, right? So add the first of B minus epsilon to the first of A, right? But why isn't it equals? Why aren't we saying equality here?
You don't want to overwrite the value.
We don't want to overwrite the value. Yeah, there may be multiple rules, right? If there's multiple production rules for A, right? When we have the bar, that means two different rules. We have A goes to something, or A goes to something else, right? And because both of those rules are possible, we can apply this by adding each of their first symbols to A, right? So this just operates on each rule in isolation, but we want to add them, right? We're trying to build up these first sets. So what happens if B has and so we saw that specifically when we just look at this, right, we want to subtract out the epsilon because we don't know what else is left in alpha, right? Just because that the first symbol on the left-hand side here produces an epsilon doesn't mean that A has to go to epsilon. It depends on the rest of the symbols in that rule, right? So that's why we have subtract and remove epsilon here. So what did kind of the next rule deal with at a high level? We don't have to describe it exactly, but what was the intuition behind there? Why do we need more rules? Are we done?
The next rule is basically if you have a bunch of different either non-terminals or terminals that all contain epsilon, then you take the very last one, remove that, and then add it to the first set of A.
Yeah, so kind of at a high level, right, we now have to deal with the question, well, what if this B has an epsilon in its first set? Right? That means there's some possible combination of rules or applications of B where B is going to go to nothing, which means that the first of A is going to be whatever the first of alpha is here. Right? And so that's what this incredibly complicated looking rule work does. But at a high level, it's doing something very simple. It's saying that, okay, if B0, if there's whatever number of symbols here, right? Here we have B's, or you can think of them as betas if that helps disassociate the non-terminal. It's not necessarily non-terminals, right? So if we have, basically what we said is if there's however many starting symbols that have epsilon in their first sets, we can add the next one after that, first set minus epsilon to A, right? So this says if epsilon is in the first set of B0, B1, B2, all the way up to BI, then I can add the next one's first set. But the important thing to note here is this is a recursive definition that applies for any I, right? So in this example, it would also apply for I is 0, right? There's a first in B0, which means I add the first of B1 minus epsilon to the first of A. And then I check, is there an epsilon in the first of B1? If there is, then I add the first of B2 minus epsilon to the first of A. And I keep going until I have to stop when there is the first of epsilon. There is something that epsilon is not in the first of one of those symbols. And I stop. I don't add any more. Because I know that those strings have to start with at least that symbol. And so the last case just deals with the situation of what happens if I go all the way through. Right? If I can go all the way through, if all the symbols on the right-hand side can produce epsilon, then there's one possible combination of trees and paths where every single symbol is going to produce epsilon, which means that it's going to be the empty string, right? Epsilon, which means that A can also produce epsilon. So that's all that this case says. It says, hey, if I go through every single symbol, terminal, non-terminal, whatever, and I got all the way to the end, then I can add epsilon back to the first of A. But only in that case, right? So does it make sense?
So is 4 just kind of to be applied with 3 because in 3 you can encounter multiple betas, right?
Exactly, yes. So 3 always applies. So this is the thing, right? 1 always is our base case, 2 always applies, 3 also always applies, right? Every single rule is going to have some A goes to B, right? A goes to beta. It's going to have some leftmost symbol. If it's just the one symbol, then this rule will apply, right? All these other rules say, hey, what happens if epsilon is in those symbols? What do I do? So the idea is, well, if epsilon's in B here, then I go to the next one, the next symbol. And then I always add the one after it. And then I check that one. Hey, was epsilon in the first of that? Then I go to the next one. Yeah?
When you say epsilon is in the set of B, do you mean is like the only thing in B?
So what's this testing? What's this operation?
Oh.
It's just set membership, yeah. So saying, is epsilon in this set? Exactly. So, yeah, it's just saying, is it one of the elements in this set? So it doesn't have to be exactly epsilon, and that's it's an important thing because, remember, the first sets are all possible strings that terminal, non-terminal generates. What are the first terminals that it could possibly start with? And so if there's some combination that it starts with the empty string, then there's going to be an epsilon in there. All right, so we start calculating. So let's say we have this grammar. S goes to A, B, C, D. A goes to C, D, or little a, big A. B goes to little b. C goes to small c, big C, or epsilon. And D goes to little d, big D, or epsilon. So does the fact that this is more complicated than what we've done change what we do?
No.
No, yeah. We do the rules, we apply the rules just as we have them to this. We can do it if you give me or I give you, or however you want to think about it, like 20 of these rules with a lot of symbols, you can just do it. It's just applying the rules over and over. So the way I like to do this, and the way to help you make sure you're doing it correctly and you know when to stop applying these rules, I build a table. So on the left-hand side, I have each of the first sets. So I have at the top the initial state, and then I'm going to put each transition of applying these rules to each of the non-terminals. What happens when I apply those rules? Right, so I start them off. My initial condition is all of them are the empty set. Now this is really important because one thing that you're going to be tempted to do, right, this is a recursive definition. So when you go to program this or when you go to write it, you'll say, okay, this is easy, right? So I calculate the first set of S, which means I have to calculate the first set of A, which means then I recursively go to A, try to calculate the first set of A. Well, the first set of A is either little a or the first of C, so now I've got to go calculate the first set of C. And you get stuck in this recursive hellhole in some sense. And because there can be loops, if you program it like that, you're never going to stop. You're going to keep trying indefinitely to calculate first sets, and you're your program's gonna crash. So this is why we do this in steps and we pre-calculate essentially the values. So when we say, on our first go around, we say, okay, I want to calculate the first set of S. So then I say, okay, my rule says I apply the first of A minus epsilon to add that to the first of S. Well, what's the first of A?
Versus C or A.
It's right there on the board, staring in the face.
C. Big C or little A.
No,
Empty set.
it's the empty set. Yeah. This is why we start with it's the empty set. We'll see that everything propagates correctly by continually applying these rules, but this is actually a very important point that will help you not get too far ahead of yourself when you're doing this, right? This is why we pre-calculate it when I say, what's the first of A? I don't have to look at anything else. All I look at is my table here, and I say, well, currently A is the first of A is the empty set. So that's what I'm going to use. I take the empty set, I subtract epsilon from it, I remove epsilon, there's still the empty set, and I add that to the first of S. So it's the first of S there. So now I'm going to move this out of the way, and we'll put the rules here. So, which rule did I just try to apply by calculating the first of S?
First of A. Oh, which rule?
Which rule?
3.
3? So take rule 3. So add the first of A, right, to the first of S. The first of A minus epsilon, we already said the first of A is empty set. So that's going to be the empty set, right? So now when I calculate the first of A, right? So which of these rules do I look at when trying to calculate the first of A? The production rules, these grammar rules. We'll number them 1, 2, 3, 4, 5. Which rules do I look at? Do I look at 1? And then look at 2, and then look at 3, and look at 4, and then look at 5? Look at all of them?
So, rule 2 doesn't apply currently because...
Not rules.
Oh.
Not rules. We don't even think about that. We're calculating the first of A, so we kind of know what we want to go to. So which production rules do we look at?
C, D, and
Of these production rules, do we look at this?
Oh, yeah.
No.
No.
Do we look at this?
Yes.
Yes.
Do we look at this?
No.
This?
No.
This?
No.
Exactly. So we only look at, we're interested in calculating the first of A. We only look at rules where A is on the left-hand side, right? Because our rules, that's the only way we add first sets, right? Each of those rules says, hey, if there's, to calculate the first set for a left-hand side symbol, check these things on the right-hand side and do these things, right? But that's the way we update. So we can completely forget. We don't have to look at anything else except for that, the rule that has A on the left-hand side. Now, once I get here, right, how many rules are there of A goes to something?
2.
2, right? That's an important thing. So we're using the bar here, but there's really 2 rules here. So let's take the first rule. A goes to CD. So which of my 5 rules, my first set of rules, do I apply?
3.
3? So which one here is the leftmost symbol? C? Big C? So what's the first set of big C?
Empty set.
Empty set.
Empty set. Yeah, so we take that, subtract it, epsilon from it, and add it to the first of A, which is still the empty set. Right? So do any of the other rules apply?
3 still applies to little a.
Yeah, so 3 still applies to little a, but just looking at CD, right? So those other rules don't apply because there's not an epsilon in the first of C. Right? If there was an epsilon in the first of C, I would add the first of D minus epsilon to the first of A. But there's no epsilon in the first of C, so I'm not going to do that. So that's the only rule that applies. So then let's look at this next rule, right? So applying rule 3 to the next rule, which of these symbols matches to our B or our beta in our rule?
Little A.
Little a? Yeah, so what's the first set of little a?
Little a.
But how do you know it's not in any of these?
It's rule 1.
Rule 1, yes. right? So rule 1 says, hey, the first set of little a is the set containing little a, and so we take little a and we subtract epsilon from it, right, which is the set containing little a, and we add that to the first of a. So after applying this, we have the first of a here. Right, so hopefully part of the thing that you should kind of be seeing and start to, right, is before when we try to calculate the first of s, we use the first of a as the empty set, right? But next time when we go through again, we're going to use this set that contains a, right? So this is how our values are going to propagate through. Yeah.
So quick question for you. So the reason why we didn't, so you're saying we went over big C and big D, right? For the first of A. But then the reason we didn't choose any elements from those, from their first set, is because their first set is the empty set, right?
Exactly.
Okay.
We did. We still performed the calculation. So, exactly.
We still went through them.
Yeah, so this is what gets you, right? So algorithmically, when you write this as a program, right, you just take whatever's in the first of C that you've calculated, you subtract epsilon from it, and you add it to there, right? You're just doing set unions, so you can do that with the empty set, and it doesn't change
So,
anything.
so based off of that, if we would have pretty much computed first of C or first of D first, and then first of A, it would have been, for example, little c.
Exactly, yes.
Okay.
But yeah, you can actually do these rules in any order.
In any
You
order
just
you want.
keep applying them, and we'll look at the condition of when you stop is when one column is exactly the same as the other column. So when you've gone through, applied all the rules to all the non-terminals, and there's no changes, that's when you stop. Yeah.
Why are you subtracting epsilon from C? Like, how come you're not looking at little c again?
Here?
Like, you know how you looked at the first big C,
Yes.
and then you said, you know, you subtract epsilon?
Correct. So what's the first of, with the first of C?
Oh, okay, I got you.
Yeah, so you got to use these values, right? And this makes it simpler, right? So you can, at every step of this, oh no, there's actually still coffee. I don't know if it should. Is it considered floor coffee if like coffee was going in? I think it's fine. I'm gonna drink it, so don't judge me too much. That's weird. That actually, it's about half full still. All right, that's cool. I blame the question. Just kidding. All right. Okay. So one horrible accident today. Good Friday. All right. So what was the question? I just got it. Very
You
excited.
answered it.
Okay. Cool.
At least something
Crisis
came
mode.
out.
All right. Perfect. Okay. So now I want to calculate the first of B. Right. So then, which rule do we apply?
B's rule. 1, 2,
Rule 3 first, right? We apply rule 3. So what's the leftmost symbol of the rule B goes to little b?
Little b.
Little b, right? So what's the first set of little b?
Little b.
The set containing b, right? So we take the set containing b, we subtract epsilon from it, and then we add that to the first set of big B. Yeah.
So you're saying you always apply rule 3? Because I thought it was only if there's like 2 symbols.
Alpha is a sequence. A sequence can be 0, right?
Oh, okay.
Exactly. Yeah. So that's the other trick. That's why you only look at that symbol. So it just means you don't have to special case any rules for anything like that. You always take the leftmost symbol, even if there's only one symbol. Kind of like when we talked about leftmost derivations and rightmost derivations, right? If there's only one, it's both leftmost and rightmost. Right? So and then we get the first set of B is the set containing little b. Then we want to calculate the first set of C. Right? So how many rules do we look at here? Or which of these production rules do we look at? Four?
Yeah, C.
Which production rule?
The one that has the C.
One that has C on the left-hand side. Yeah, that's the important thing.
Keep getting
Right. Production rules. Production rules, first set rules, I know. Kind of realized that as I said it. Okay, then we have, oh, thank you. That's very nice. I'm just stuck, okay. Teaching and cleaning. All right, so now we want to calculate the first set of C. So what is the first set? So we look at the first rule, right? Big C goes to little c, big C. And then we take the, so which rule do we apply then?
We take the little c.
Rule 1? Rule 3.
Rule 3, right? So which of these symbols do we want to take the first set of? Big C or little c?
Little c.
Little c, right? And so the first set of little c is?
Little c.
Little c, we add that there, right? So we get the set containing little c. And then what about the next rule?
We do the epsilon.
So this is actually a tricky one. So this gets back into precisely applying these rules, right? So let's see if we can actually precisely apply these rules here in this case. So we have C goes to epsilon, right? Which rule do we apply?
Rule 3.
Rule 3, right? We always apply rule 3, right? So we're trying to calculate the first set of C, right? And we say, okay, then we take the first set of the leftmost symbol. So what's the leftmost symbol here?
Epsilon.
Epsilon. Yeah, so what's the first set of epsilon?
Epsilon.
And how do you know?
Rule 2.
Rule 2, right? Epsilon. But what does rule 3 say that we add to the first set of C?
The set minus the second containing epsilon.
Yeah, the first set of the rightmost, of the leftmost symbol minus epsilon. So what's the second containing epsilon minus epsilon?
The empty set.
The empty set. So then we add the empty set to C, right?
That's tough.
But, so we just applied rule 3, right? Does rule 4 apply? Let's think about that. When would rule 4 apply?
If epsilon is in the first of B0 and et cetera, then it essentially is saying that for all B of n, if epsilon is in B of n, then you check the first of epsilon B of n plus 1.
You don't check, you add it always. Yeah,
So
that's good.
the fourth rule would have applied if the first of little c in this case would have had an epsilon in it.
It's not. Oh, it would have for the other rule, right? But we're looking at the second rule here of epsilon, right? So, okay, the first thing to ask yourself for a question for number 4, right, is there an epsilon in the first set of the leftmost symbol? Yeah, there is, right? Yeah, we just computed that. There definitely is. So then rule 4 says, okay, then you can add the next symbol to the first set of A. Is there a symbol?
No.
Yeah, so we can't add anything, right? So that rule 4 doesn't apply because we can't add anything after the epsilon. But what does rule 5 say?
Because all the preceding.
What does it say?
Epsilon still counts. Add it back in.
Right. Well, so rule 5 says, right, if there's an epsilon in every single one of the symbols, then add epsilon to the first of C. So does that rule apply here? Yeah, we have one symbol on the right-hand side. Is epsilon in the first set of that symbol? Yeah. Right? So then we can add, then we add epsilon to the first set of
So
C.
we take epsilon out and add it back in.
Yes. So this is so obviously when you're looking at this, when you have C goes to epsilon, you know you can add epsilon to C, right? So you don't have to go over all of this rigmarole, but this is showing you that the rules are consistent, and this is how your program should work, right? So you don't have to special case epsilon at all. You just apply these rules over and over again, right? So you have a fifth rule that checks, hey, is there epsilon in the first set of all these symbols? If so, then add the second containing epsilon. So that's what actually propagates this. That was an important point I wanted to make. Yeah.
So how do you know to apply to the third rule instead of the second rule when you're checking C there?
Because I'm trying to calculate the first set of big C, right? The first rule only applies to terminals. Is big C a terminal?
No.
And then the second rule applies to just epsilon. Is big C epsilon?
No.
No. So I know I have to start with rule 3 because rule 3 always applies to any non-terminal.
Okay, because it has the or symbol, therefore means that you have to apply rule 3 essentially.
The or symbol just means that there's another rule. So I could write this as C goes to little c big C, and I can have a new line and have another rule that says big C goes to epsilon. That's exactly the same. So it'd be the same thing if you got rid of this and just had C goes to epsilon. So you first have to apply rule 3. And then by applying that, you apply rule 2, right, to say, okay, what is the first set of the leftmost symbol? Well, in this case, it's clear, it's epsilon. But then you actually remove it and don't add it until you apply rule 5. I'm hoping this will help on programming, right? That's why we want to talk about this and think about this as mechanically applying these basic operations. Okay. So what's the first set of D? We don't have to. We can do a little bit of
It's gonna be D and epsilon.
D and epsilon, right? Yeah. So applying this to this rule, we take the leftmost symbol right? Rule 3 says we take the leftmost symbol, and then rule 1 says, well, the first of that symbol is the second containing D. We add that to big D, and then we do the exact same thing we did with epsilon, so we're going to get epsilon in here. Cool. So the question we have to ask ourselves, we've gone through all of the non-terminals here. So are we done? Can we stop and say these are the first sets, we've calculated it, we're done, let's go home?
No, because things have changed.
Yeah. Right, that's how we know we're done. When two of these columns are identical, right? Are these columns identical? No, we made a change, right? So we have to do it again. We apply these rules over again. So calculate the first of S. Which of these grammar rules do I look at 1 through 5? 1. Yeah, only 1 because I'm just looking at the first of S. And then which rule do I apply? Rule 3. So I add the first of what to what?
First of A.
First of A to
The first of A minus epsilon to the first of S. Yeah, exactly. Which is going to be what?
Little a.
Little a, the second containing A. Yeah. Cool. Now I take first of A, right? I want to calculate the first of A. Right? So I look at this rule first, right? A goes to big C, big D. So I'm going to add which symbol here? So I'm going to apply this rule, right? So which do I try to calculate?
The first of C.
The first of big C?
Yep.
Right? And so, what's the first of C? C epsilon, right? Yeah, we got it right here. This is where we look, right? We don't look at the rules, we don't have to look at anything except for this table that we've created to say, okay, last time we did it, the latest value is C epsilon, right? We don't want to use this value, right? Because this is an old value. The empty set is an old value, right? We want to use the new value. Okay. So then I say, okay, so by applying rule 3, what do I add to the first of A?
Little c.
Little c.
minus second epsilon.
Yeah, so right now the first of A is going to be the second containing A and C, right? Little a, little c. I specifically don't add epsilon, even though epsilon is in the first of C, because I'm subtracting it out, right? Cool, so do any of the other rules apply?
Yeah, the
Other
fifth
A,
one.
the little a.
The fifth one maybe. The fifth one you only want, well,
Isn't it because that first contained at the end an epsilon, so you would add it back in, right? Or am I not understanding that correctly?
the rule is correct. Okay, so these are there's two different things, right? There's the mathematical rules, which we can apply in any order, and as long as we apply them all correctly, we'll get the right answer. So we can actually apply Rule 5. So what does Rule 5 say?
That after going through all the first sets in your rule, if epsilon is at the end,
Yeah, so how do I actually calculate that here? What are the conditions here? How do I know if that applies?
C and D can both be epsilon.
C and D, what do I look at for C and D?
They can both be epsilon.
Yeah, so if all of the grammar symbols in this rule, right? So do I look at little a, big A?
no.
No.
No, because I'm not even considering that right now. Only focus on this rule, right? So I can say, hey, is there an epsilon in all of these symbols in their first sets? So what's the answer?
Yes.
Yes. So yes, I can add epsilon there. So yeah, we can definitely do that. That's something we can do now. For me, I like to think about it a little bit algorithmically, right? Like, so how am I going to actually compute that? So I just added the first of S to the first of A, right? So I added the first of C minus epsilon to the first of A by applying Rule 3, right? But I haven't actually gone through and looked at each of the symbols yet, right? So I wouldn't really apply Rule 5 now. What I'd think about is, does Rule 4 apply?
Yes.
So what does this mean? How do I apply this to this rule, to this production rule?
Basically means if this first of C contained epsilon, then we move on to D. So the first of
Yeah,
D.
so if the first of C contains an epsilon, that's it?
Yes.
Yeah. Then I add the first of D minus epsilon to the first of A. So what's the first of D minus epsilon?
D. The second
D. The second containing D. So A now has A, C, and D if we did it in this order, right? And then if there was a symbol after D, then I would say, hey, is epsilon in the first of D? Yeah, then add the first of whatever comes after it to the first of A, right? But there's nothing after it, and then this is when I do my check. Okay, did I go through all the way? Is there epsilon in all of these first sets?
Yeah.
Then I would, which is yes, right? And then I add epsilon there, right? So now this rule applies, rule 5, and so I add epsilon in here. So now I know the first of A is A, B, C, D, epsilon. Yeah.
So when we computed the first of A just now,
Mhm.
we took rule 3 first.
Say it again.
So we computed rule 3 on the first of A, right?
Mhm.
So then how do we have an epsilon if we minus the epsilon from the first of C?
Right, so we applied rule 3,
Yeah, and then we took out the epsilon. So first
then we
of
took
C,
out the epsilon, then we just added C. Exactly.
Yeah, so then first of C doesn't have an epsilon.
Correct. So we added, this is where we got the C from, so
Yeah, no, I understand what you got to say.
Okay,
I
okay.
understand why
I'm
you
taking-
got an epsilon.
You don't change the first to C. You just add the first to C minus epsilon.
yeah. Yes. So we only add, and we're only changing A because we're only looking at that rule A.
Okay.
So yeah, that's a good point. So we call, think of it like a function call, right? We call the first of C, it returns something,
Right.
and then we take out epsilon from that set without actually changing the first of C.
Okay.
That's a good question. Cool,
What
yeah.
about big A? Did we touch that?
Big A?
Yeah, the second.
Yes, okay, great. So actually, yeah, so we would apply this, so we actually didn't do that, I kind of skipped over it, that's a good point. But before we're done here, right, we say, okay, we finished with this rule, this production rule, A goes to CD. But then I gotta look at the next rule, right? So which one of my 5 rules applies to this, my 5 first set rules? 3, right? So I do the same thing I did. I do 3, and then I say, okay, add the first of little a to the first of big A. And I know by rule 1 that the first of A is the set containing A. So I add that. A is already in there, so sets, right? So sets are just, order doesn't matter, and you can only have one of each element. So if you add A to a set containing A, right, you still have A. Yeah, it doesn't change it. But once again, algorithmically, you would just do that, right? You just apply all these rules as many times as you can for each of these non-terminals. Yeah.
For the project where we're going to be programming this, does order matter?
No, it shouldn't. If it does, you're doing it wrong.
Okay.
So yeah, no, that's the nice thing about this. You can just apply these. You can go over these non-terminals in any order. You can apply the rules as long as you're always grabbing the latest first set from here and not trying to recursively calculate it. That's when people get into trouble. Okay, so the first set of B. The change.
Rule 1.
Oh, yeah, rule 3, then rule 1, right? So you add B back into there. There's already B in there. Ooh. Mess today. So that doesn't change. Then we do C. Same thing, doesn't change. And we do D.
No change.
No change. So that actually gets into a good point about the question about do we take out epsilon from C, right? So this is another way you can self-check while you're doing this. So think about it this way, right? We're only ever adding things into sets, right? Every time we apply rules, we're only adding things. So all of these sets should only ever be growing, they should never be shrinking. Right? So if you ever have a step where you got rid of something, you've done something horribly wrong and you should go back and re-look at the rules or something. Right? So that's another good way to check. So, am I done? I went all the way through.
No. S isn't done.
Yeah, we're not done. We gotta do it again. Do it again. Okay, so we do S. So which of our rules do we apply to try to calculate the first of S? 3. So what's the first of A? ACD and epsilon. So do I add ACD epsilon to the first of S?
No.
Yeah, CD. Because they do CD. And then
Right,
subtract epsilon.
ACD. So I take out epsilon.
Yeah.
Right, so now the set first of S contains A, C, and D. So am I done? the important rule. So rule 4, right? Rule 4 says, hey, do I add the first of the next one? And I know I add the first of the next one when the current one, the one I'm looking at, the leftmost one, has epsilon in it. So is epsilon in the first of A?
Yes.
Yeah. Then I add the first of big B there, right? Minus epsilon to the first of A. So my set for the first of S is A, C, D, B. So then do I add the first of C to the first of S?
Yeah.
Because
No.
the set.
Does rule
first of-
4 apply again?
No.
Well,
Because
no.
the first of B did not use an epsilon.
Yeah.
Yeah, so B does not have an epsilon, so I don't add the first of C, right? That's the important point. That's when I stop. So does rule 5 apply?
No.
No, right? We didn't reach the end. There's not an epsilon in all of these symbols, just in the first one. Right? Which kind of makes sense with the intuition of the first sets, right? So S, all the strings that S could possibly generate, right? A could go to nothing, the empty string, right? Epsilon. But B is always going to be a single B, right? So it's not possible for S to generate a string that is empty. There has to be always a little b in there. So when I calculate the first of A, how does my set change?
All right, remove the epsilon.
It doesn't change.
Doesn't change, right? We had the first of C, we had the first of D. We'd take out epsilon, then we'd add it back in because we went all the way through. Then we'd add the first of A, and none of that changes. B, first of B.
No.
Nope. First of C.
No.
Nope. First of D.
No.
Nope. Do I stop? Am I done?
No. One more time through.
One more time. Well, you only know it's one more time because
Because the boxes.
the columns. Yes. We've reached the end of the PowerPoint slide, so we know we're done. That's not how you should do it. So first of S, right? When I calculate the first of S. So what's the first thing I do? What do I add to the first of S? The first of big A minus epsilon, right? A, C, D.
No change.
And then do I add the first of B?
Yes.
Yeah.
Yes, because there's an epsilon in the first of A. So I add the first of B minus epsilon. Do I add the first of C?
No.
Nope.
You're done.
So then I stop there. This one stops. This one stops. This one stops. This one stops.
Now they're all the same, so we stop.
Now the sets are all the same. We've applied all the rules, so now it stops. Right? And it kind of makes sense if you think about why do we keep doing it until it doesn't change, right? So every time we apply the rules, we're adding something to the sets, right? The sets are always growing, and each of the rules depends on the first set of the other rules.
So you keep on going until you don't change any of the sets.
Yes. It's called the fixed point, but you don't have to know that or anything. But in general, in the future, when they talk about theory stuff or fixed point or whatever, this is what it means: is you've reached a point where you're applying all these rules, doing all these things, and you're not actually changing the sets or anything. And you know that you're done because hey, every time I add these rules, I better be adding something to a first set, and all the rules depend on the other rules' first sets. So if I never change anything by correctly applying all the rules, then I know I'm done, right? And you can even, this doesn't mean that you actually, you have to stop here. If you want to do a self-check and do it one more time by applying all those rules, better make sure it stops there. All right, one thing. What if I change this A over here to be A, big D, right here, on this left-hand side? Would I be able to do that, or would everything fail? When I start here, right, I say when I calculate the first of S, and I calculate the first of A. So if this big C is an A, when I calculate the first when I try to calculate the first of big A, which rule do I apply?
Pretend like it's epsilon.
Rule 3, right?
Rule 3?
And then
Yeah.
it wouldn't actually crash because you would a first of A minus epsilon, and then the first of A could be small a, big A, and then you would just take A, so it would be the same thing. Right?
Yeah, close. What do we use? So here we have basically A goes to A alpha, right? We add the first of A minus epsilon to the first of A. So do we get a horrible recursive
A little bit.
call?
Well, you have multiple rules in A, so you just try the other rule.
But I already know the first of A. Right? The first of A is the empty set.
Would be empty set A.
Exactly. So when we see this, we say, hey, the first of A, I just look it up here. It's the empty set. I say empty set minus epsilon.
Done.
Boom, done.
What was it? What do you do on the next iteration?
On the next iteration, there'll be an A in there, right? Because there's an A here. And so I'll just add in the set containing A minus epsilon to the set containing A. I mean, it's not going to change, right? If you union a set with itself, it doesn't change.
Right.
But the critical thing is, this is why you can't do this recursively when you program it, right? The important thing is there's no special case that it's the fact that it's the same, right? Whatever this symbol is that you're trying to calculate here, the first of B, right? You just look it up in the table.
So though these rules are recursive, to apply them recursively is not the best approach.
Yes, absolutely. Yeah. So you can think about this as like, what's the last seen value of the first of B? So that's what's important. So.